My name is Marco Rogers. I work for Yammer. And this talk is about, as you said, finding patterns in front-end JavaScript development. So we spent a lot of time talking about JavaScript libraries and frameworks, which one to choose, when to use them, when to write your own, which is hopefully never. But unfortunately, I'm not actually going to give you answers to any of those questions today. What I actually can do is give you a peek into the way I think about front-end development today, because there was a point where I realized that there are lots of shared patterns, and if we look at those shared patterns, it'll give us better insights into the landscape of how we build things today. So let's see if we can move forward. A while back, I wrote this on Twitter. I tweet sometimes. And the question that I got back most, I had some people agree, but the question I got back most was, what are the patterns that you see? Like, people wanted to kind of discuss this, which I thought was great. So my goal with this talk is to provide sort of a mental model for pulling out these patterns, being able to identify the core concepts, and being able to kind of discuss them across different libraries and frameworks. This is going to be an incomplete list, because this stuff is still evolving, and because I don't know everything, unfortunately. But I think the best outcome for me is when I get done with this, that you're like super annoyed that I didn't get to go further into it, and that you want to continue the conversation, because I think that we need to. So let's kind of talk about the three main buckets that I put these into. The first is common patterns, right? So these are kind of the core patterns that people, or at least in my mind, the core patterns that people are referring to when they say MVC or MV star-ish kind of thing, right? So we're going to take a look at one of those, and it's going to be kind of a baseline for what I mean by that these are shared patterns across frameworks. I'm going to dig into the advanced, some of the more advanced abstractions on top of the MVC-ish thing. This I think will be interesting for illustrating what I think a lot of us are doing today when we're trying to build complex web apps, whether we're using a cohesive framework like Ember or Angular, or whether we're using our kind of custom-built thing that is about 5 years old and which nobody really wants to use anymore, and yet it's still kind of hanging around. I think you see the same patterns across all of these things, right? And then finally, we'll look at some emerging patterns. These are ones that are less common, but I think are coming up more and more frequently as we try to build apps with more sophisticated capabilities. So let's kind of jump right in to common patterns. And they look like this, right? So models, views, I want to be pretty obvious. Hopefully should be pretty obvious to the folks in this room. Controllers, the C is always kind of nebulous, but I think routers and controllers are kind of come with that. And routing is probably the more important feature for building single-page applications, right? Being able to route to a particular view. And then like RESTful API access, because obviously you need to get some data and shove it into your UI. I think these should be pretty familiar to people. We're going to jump into one of them so I can kind of illustrate what I'm talking about. So let's talk about models, right? This will be a rehash for folks. And it comes with these capabilities, generally. At least this is my contention. This is how I kind of outline this pattern in my head. You get some objects that represent your data model, right? You can inspect the properties on that object. You can read and write them. Usually you can persist data to the server because that's handy sometimes. And then the most important part that I think makes this into a pattern and not just kind of the thing that we do with JavaScript all the time is that this model layer is going to fire change events. It's going to tell you when these models have changed and allow you to register a callback so that you can respond, right? And that allows us to take this model layer, decouple it from the other parts of our app, whether it be our views, templates, what have you, but still be able to make it do interesting things, right? So does this make sense to people? It's not making sense? Rehash? Thanks. That's probably good. So let's take a look at how Backbone does this. Backbone should be familiar to most people. This looks pretty straightforward. You create a new Backbone model, right? Give it some data, ID, this latest reply at, which is kind of a date string. You can inspect these properties by pulling out the ID and comparing it to some other things. And Backbone wants you to use a getter for this. And then you can register a callback, right? And in Backbone, it looks like this. It uses this nice kind of event listener pattern that was popularized by jQuery and Node.js, depending on who you talk to. And so when latest reply at gets updated, this callback is going to fire, and we can do things. And then finally, we can update this model by calling this setter. And when we do that, then our callback's going to fire. This isn't a surprise to anybody, right? This is kind of what we do. This is kind of the core of Backbone models. But let's kind of compare it to what I work with every day, which is the internal framework that Yammer uses, which we call Yammer.JS, or sometimes affectionately Yamjuice. And it looks like this. Let me go back. Here's Backbone. Our framework looks like this. That slide did change. They're very similar, but it did change. And you can kind of see that it's actually doing the exact same thing. We're creating an instance of this thread model, giving it some data. We can read the data directly from the property without using a getter, because that's how our framework works, but it amounts to the same thing. Then you got this funky looking hook thing where we're asking, when this thread has an update, register a listener, right? It's not as nice as the event listener pattern that we all know and love, but it's essentially doing the same thing, right? It's allowing us to listen for changes. And then when we want to change this data, we have to go through this setter method called update. And instead of changing one property, we change multiple at a time by passing a hash. And we need to use this setter so that we can get our event hooks. If I have time, I'll tell you a story about that, what happens when you don't use it. So when I recognized that this looks pretty similar to the other frameworks that I was seeing, this is when this idea of patterns started to develop in my head. Because anything that you can do with this core concept in Backbone, you should be able to do with our framework. And you should be able to do with other frameworks that say they have a model layer for you, right? But it doesn't always look this similar. And so I wanted to pull up a different example that looked a little bit different. So here's Angular, right? Angular looks different. And depending on who you talk to, it's like interesting different or like annoying different. But it's different. But the outcome is actually not that different, right? It's doing the exact same things. Instead of having this object that you create, you just use plain JavaScript objects, and you shove them onto this special scope object that Angular gives you. But then you can read properties off of that thing, and you can set properties on that thing. You can see at the bottom there. And you set them directly just by updating properties like you do on JavaScript objects. But when it comes to that last thing that I said was really important, listening for changes, Angular wants you to do that a little bit different. When you shove your model objects onto this scope, you can take advantage of this watch function that they give you, which says anything that's attached to this scope, we're constantly checking for changes. And you can register for those updates by giving us this expression, right? So I'm registering this watch expression for latest reply at, and it's going to do the exact same thing as these other slides, right? When I first looked at Angular, I thought it was kind of crazy town. And then as I started to develop this pattern of what a model layer was, and I went back to Angular and I said, how does Angular let me do this stuff that I know that I should be able to do? Then it started to make sense because I started to know what I was looking for in terms of finding these capabilities. And so this example started to look a lot like the other examples, which is good for me because I need things to look similar. I'm not that smart. So now I can kind of do the things that I know how to do with model layers in my framework and in Backbone, and now in Angular to a certain degree. And each of these has further capabilities that they want to use to distinguish themselves, and some of them are really useful. But at the core, these are the capabilities that you should be looking for. Because if we go back to what I outlined as my understanding of a model pattern, it's just these four things. These are the things that I'm trying to do when you tell me that you have models, right? And I can do that in any framework that I pick up today. And if I can't, then that's going to be an indication that maybe it's not for me, right? If you know these core concepts, you can start to have a better basis for evaluating these frameworks. Is this making sense so far? Cool. So let's kind of jump into advanced patterns. I obviously won't be able to hit everything today, but I've got kind of an example for each one of these. As apps get bigger and more complex, these core MVC patterns, they start to fall short, right? Like they're not cutting it. As your app gets bigger, as you have to maintain more complexity, you want better abstractions on top of these core patterns that allow you to manage that complexity. And this is where you get into advanced patterns, right? This is what advanced patterns look like to me. This is, I think, kind of at the core of what I look for when somebody says that they have a new framework that I should check out, right? Nested views, this is the idea that you're going to take the outcome is a big complex UI, and you want to break it down into something that's more modular and still composed together such that you can kind of treat it as a single entity. And we'll look at that example so you see what I mean. Complex rendering comes into play, right? It's very easy to take your one model and smash it into this one template, and like if that works out, it's great. But sometimes you have to do more things. Sometimes you have to maintain the state of whether this item was collapsed or closed, and sometimes you have to like format dates, and sometimes you have to do these other things that aren't just like kind of a straight mashing of templates. And a framework should hopefully help you do that stuff. Model relationships. This is the idea that when your client-side app becomes more complex, you want to take this model layer that you're familiar with and start to have better tools for representing your entire data domain, right? So maybe you have some messages and you need to know which user sent them. You want to be able to take that message and say get user, and it'll give you back this particular user kind of automatically, right? So you start creating these like has many relationships and these belong to relationships, and essentially kind of recreating your schema on the client because it sounds like a really awesome idea. And then later you might regret it, but in the meantime you're like really jamming, and this is the kind of thing that I consider a really advanced pattern that when it's working well, works really well. Local data caching, this is the idea that you've routed to a new view. And maybe it's one that the user has seen before. You've got all the data for that view. Nothing has changed. But do you still have to make another AJAX call just in case, right? Do you know if something's changed or not? Are you caching all that data locally so that you could just reuse it, right? And it allows you to do things like fast UI switching. So local caching and two-way binding, I think, is on everybody's minds today. And a lot of the big frameworks are pushing it because it allows you to make complicated updates to your UI without writing a bunch of glue code, which is sometimes nice. So let's kind of dig into one of these. I like nested views. It's the advanced pattern that I think needs to go on top of every framework, and if I don't have it, I'm really annoyed. But first, a quick refresher on what I mean by the kind of core view pattern. It doesn't do much. Render some markup to your DOM, right? Respond to user input from your DOM, and subsequently, when things change, update your DOM with some things, right? Pretty straightforward. I hope this is non-controversial. What we want to do is put a pattern on top of that says, we're going to allow you to take this core view and compose them together to create more complex structures, right? And a nested view pattern kind of goes like this. So you can take these views, you can organize them to a parent-child tree, right? When you render at the root of that tree, it's going to recursively render down all of the children without you having to do much work, rather than you having to go and touch every part of this UI and create this object for your views and pass in models and whatever. All that's done once by recursing down the root of this tree. And more importantly, but harder to define, this tree has a shared lifecycle. And what I mean by that is this rendering process you can reason about. You can say, when I call render on the root of this tree, either it's synchronous, and when render comes back, all of my children are rendered, or it's asynchronous, and it's going to say, OK, I'm going to return immediately. I'm recursing through this rendering, and when it's done, I'm going to fire an event. I'm going to say you've rendered some things, and then you know what the state of this tree is, right? And subsequently, when you're done with this tree, you can take that root and you can call destroy or remove or dispose or whatever it is you decided to name it that week. And it's going to recurse and clean up for you, right? It's going to go through those children, take those objects, destroy them, unhook listeners. There's all these implementation details, but you want that thing to be nicely able to be reasoned about. Otherwise, you're going to have like huge memory leaks, because that happens to some people that I know who are not me. So this idea of nested views I think is really important, and I want to kind of jump into it a little bit. So I want to talk about YamJuice first. This is actually an illustration of a Yammer threaded conversation, right? You get a list of these in your group feed, and so we want to render this thing, but we don't want to do it all at once in one kind of huge module. We want to break these pieces down into things that can be kind of reasoned about independently. So we've got the first kind of thread starter message, and it's called out. It's more prominent. It might have little attachments on it and whatever else. And then at the bottom, you've kind of got the list of replies, which are less prominent. There's a list of them. You can tell who replied to who, and they've got a different look and feel. And so we end up with 3 primary views in order to render this. We've got our kind of high-level thread list item. We've got a thread starter that encapsulates the starter message. And then we've got multiple message list items for our replies. And we want to be able to handle this in a way that's nice. So this is what it looks like in YamJuice. It's not that nice, but it's been working out for us, right? So you create this thread list item. Ask me later why that's called a backbone component. We're definitely in the middle of replacing some of these patterns with standard backbone implementations. So you create this thread list item, but inside this thread list item, you're going to do a couple of things. You're going to add your thread starter as a child view. So you create your new thread starter, and you prepend it to this thread list item. And then you're going to loop through all of your message replies, and you're going to turn those into message list items, and you're going to append those also. So these views have all been instantiated, and they're now all composed together underneath this thread list item. And then all I have to do is create this thread list item and call render. And when I'm done, all this stuff's done. It looks like that, and it's great, right? And I didn't have to go through a lot of munging or whatever. I just had to set these up once, create this parent-child relationship, and this just happens for me, right? Not magically, but in a way that's like a nice abstraction, okay? Is this a thing that people are generally familiar with or have seen in various places? Cool. So when we look at other frameworks, we can see it being similar in some ways. I chose Marionette because I think it's one of the more popular advanced pattern frameworks that are built on top of Backbone, which I think is cool. And it allows you to do a very similar thing. For your message list items, which is your list of replies, you're going to create an item view. And for your thread list item, which is your kind of encapsulating view, you're going to create a composite view, because Marionette says if you create a composite view, we know that we're going to render some children recursively, and it has that whole thing kind of built in. And you've got less boilerplate involved. You can just pass it. You can say, I'm gonna do a message list item underneath here, and then you create this thread list item, and you give it some collections, and like, boom, like things start happening, right? So you just call render, and you get the right thing. I haven't used Marionette as much as I've used some of these other frameworks, but as soon as I looked into it, I said, I bet Marionette does this. As soon as I looked into it, I found all the right elements to be able to create the thing that I was trying to create, the thing that I knew that I should be able to do if this is a serious framework, right? So people are having these same ideas, right, independently of each other, because this is a pattern that's kind of emerging in people's minds, and it's not a new thing, right? Like this is based on prior art. Like we know that these things are useful when you're building complex UIs, and we're just learning what are the right ways, or what are the most interesting ways to build them in front-end JavaScript, right? So these things look very similar, but I always want to kind of pull one that looks less similar, and I wanted to mess around with EMBER.JS some more. And the EMBER.JS example looks like this. For this, I decided to use custom components instead of nested views, right? And this is the thing where you can kind of stick these kind of custom names into your template, and they're an encapsulated version of the view that knows how to render itself and has this encapsulated behavior, but allows you to still kind of nest things just like you do with HTML, with normal HTML. And Ember's tracking this against the web components standard that's developing right now. So with Ember, I kind of created this component called a message list item for the internal one. I left out the thread starter, but you kind of get the drift. And then your high-level thread list item template looks like this. So I'm making a thread list item. First thing I do is kind of stick my thread starter in there, and like that's all I really have to do. As long as it has access to the right model for that thread starter, it knows how to render itself. Like this template doesn't need to be bothered with the details, but they're now composed together, right? And then I loop over my replies, and I do the same thing. I create message list items, and I pass in each reply, and it knows how to render itself. And you should get something that ends up looking somewhat similar to the threaded conversation that I had before in Yammer. In fact, when Yammer was evaluating new frameworks, this is basically the exercise that I went through. I pulled every framework that I thought might be interesting, and I tried to build a Yammer feed with it, right? I tried to see how far I can get, applying these same patterns that I've already used with the internal framework that we have. And I'm like, this framework should allow me to do all these things in a similar way, or at least one that I can reason about. And I got to varying degrees of success based on the factors of the opinionation of each framework. But it was a really useful exercise, and I started to see these patterns emerge. So the outcome here is very similar, right? We get this kind of nested view. But the thing that I think is really interesting here is that I think a lot of people get thrown off because this is template-driven rather than JavaScript-driven. Ember and Angular both, I think, prefer to be template-driven. They kind of want you to think about what your markup is and give you hooks into it that allow you to kind of hook into your behavior. But I prefer the opposite, right? I prefer to organize my JavaScript objects, right? JavaScript code that does what I want, and then have these templates kind of be a side effect of that kind of orchestration going the way that I wanted. But the outcome is the same, right? Like the nested view pattern, I think, applies in both of these, even though they don't look anything alike. You can reason about them in similar ways, right? If this is starting to kind of sound repetitive, like, that's great. That's exactly what I wanted. Like, I want this stuff to look the same, because I think that's what we want when we're talking about these shared patterns, is a kind of a way to look at these frameworks that look very different and are really trying to differentiate themselves, and to say, well, if I have this kind of shared model in my head, if I have this mental model of how these things are supposed to work, because I know how the front end works, then I can use that as a basis to understand anything that these frameworks are trying to throw at me, right? And that doesn't always work, but it definitely gets you a step ahead. So let's kind of round it out with some of the emerging patterns. These, I think, are the more interesting ones, and ones that I think are harder to kind of find the patterns, or at least establish the patterns today, but definitely worth looking at because they're coming up more and more often. They kind of look like this. They're less common. They're coming up more and more frequently. These patterns aren't built into every framework yet, although the big major ones are trying. I know Ember's doing things, and Angular's doing things around making real-time more standard. And recognizing these patterns can help you kind of look across the field and see how different frameworks are trying to solve these problems that, like, I know some of you have today, and help you evaluate those, right? So custom components, we kind of just looked at with Ember, but Polymer and React are kind of at the forefront of that, I think. Real-time updates, which we're going to talk about. People's go-to is usually Socket.io, but there's definitely other things that you can grab, like Pusher. Real-time sync, which is related in kind of a, save your models locally and then have this always-on syncing thing going with your server. And then also similarly related to that is kind of going full on offline cache, right? Where your model layer is persisted locally at all times, and then there's the syncing thing that pushes it to the server if and when it can. But offline access is kind of a first-class citizen. Hoodie's kind of leading the way with that. And then finally, device capabilities, because you want to kind of access hardware capabilities on mobile devices like your camera or geolocation. When you look at this stuff and you think, yeah, I've had to do that, you've probably also gone through this exercise where you're like, well, how the hell do I do that with framework X, whatever one you're using, even if it's your custom one? And so people are kind of gluing these together with custom code that's hard to maintain. And so this is why I feel like there's a pattern emerging here, because lots of people are doing it, but it's not a thing that you recognize and a thing that looks the same. Or at least I thought so, right? So I want to look at real time, because everybody wants to be real time these days. And in fact, I was laughing because I noticed that the go-to app, which was like the to-do app that people were using as a tutorial for their framework, has now switched to the real-time chat tutorial, right? So all these frameworks are trying to differentiate themselves by having you build something in real time, because they know that's what people are looking at, right? But when I looked around at this pattern, I was surprised to find a little bit more consistency than I was expecting for something that I thought was just an emerging pattern. The way that people are integrating it actually seemed very similar to me. But as a pattern, I also felt like there was something missing. So if you look at these bullet points, obviously you can subscribe to real-time updates from the server. But the thing that I think makes this a pattern, the thing that I think is really useful here, is the idea that those real-time updates get dispatched through your normal model layer in a way that's very familiar to you, and that you don't have to spend a lot of time reasoning about real-time as separate from not real-time, right? We'll kind of see what that looks like. You can register for events just like normal models. So I looked at Angular first. I didn't write these examples. I kind of Googled around and looking for what people were doing with real-time and Angular, and I found this. So this is kind of an example of how you might kind of build a blog that gets real-time updates or whatever, right? And so you're kind of going into your Angular controller. You've got your scope there, and you give it an empty list of items that you're going to presumably fill. And you have this initial method to retrieve your initial data, right? So just do a regular AJAX call, get your items back, and shove them on that scope. And you're good to get started, right? But then to add the real-time component, they pull in this service. Angular wants you to go through these services to access data. And so they've got this pusher service that exposes this subscribe method. And it said, subscribe to whatever collection on the server will give you real-time updates. In this case, just called items, and register a callback. And every time there's a real-time update of items, we're going to fire this thing. And all I'm doing here is pushing it onto this items array. And if you remember, there's not much else here because Angular is listening for changes to this scope. So all I have to do is push these items here, and all the stuff that's listening for changes is going to update. And in this case, they're going to update in real time. And sometimes that's really all you need, right? Like that's really all you want is to say, for this particular list, I want it to update as soon as these objects come in, as fast as possible. And that's all it takes in this case. And I think that's pretty nice. It's very explicit, which is cool. But it's also kind of, like it could be better. It could be encapsulated a little bit better. I don't want to have to always worry about, setting up this subscribe in every controller that I need this real-time stuff, right? So I jumped over to Ember, Googled around a little bit, and I found something extremely similar, right? Completely unrelated, but extremely similar. This is from the Discourse folks who are heavy Ember users. And they're doing a similar thing, building a blog, want it to be real-time, updates, such and such. And they do kind of the same thing, right? So they're in their controller, create this subscribe method that's going to give them real-time capabilities. And they're using this library called a message bus, which, if I'm not mistaken, is a JavaScript client that kind of connects to this Ruby backend that gives you real-time updates. And it just exposes this subscribe method. And it says, subscribe to whatever thing on your backend you want to get real-time from. You register a callback, and it's going to give you data. And then you take that data and you shove it into the part of the model layer that you want to fire update events. And in the case of Ember, it kind of looks like this. The controller model stuff in Ember is still a little sketchy to me, but you don't need a lot to understand this. When you get some data, here's where you put it. It's going to update in real time. No fuss, no muss, right? I put citations for these two that aren't mine, so you can go and check them out. So I was surprised that these things look pretty similar, but they're still pretty explicit. They're still not encapsulated well. And so this, I think, is an interesting place to look at YamJuice again. We didn't talk about how YamJuice models are created, but it kind of looks like this. You just define a new model. In this case, we're making a feed, which is kind of that list of threaded conversations. And we're associating it with a real-time feed client, appropriately named. It's going to say, this is going to get real-time data for you and surface it in a way that you can use. And in a completely different file, this is a pretty sophisticated system, which means that it's kind of overgrown and hard to maintain. In a completely different file, you have your base real-time client, which has this connect to real-time method, and look, there's your subscribe, right? Like it's the same, right? Like if you haven't gotten the point yet, this stuff is the same. So here's your subscribe. You give it an ID, and it's going to fire this callback when your data's ready. But how does it surface that data, right? This is where the difference comes in, and this is where this pattern is a little more complete than the ones that we just looked at, because this is buried, right? This is an abstraction that's wrapped in our model layer. So the usage looks different. The usage just looks like this. You just create your model like you do in any other place, and then you hook onto this on-thread update that says if there are new threads coming into this feed collection, let me know. And that's it. Like, you don't have to mess around with the real time. This could be a regular AJAX call. This could be real time. We don't really care. All of our UI is just hooked up to this method that says if there's new stuff, I'm going to render it. And so we're encapsulated from dealing with the real-time elements of this. And so those real-time elements could change, the implementation could change, right? Like our real-time requirements could change, and none of this stuff has to change, right? That's ideally what you want from a pattern, is something that's actually modular and encapsulated like this. So I hesitated to put these last slides in because I've been doing these investigations of these frameworks, but I wanted to look at METEOR, but I didn't get very far because I think something about METEOR kind of twists my brain in a way that is not very cool. So I only got so far with this, but I did recognize that METEOR, I think, is establishing this real-time pattern in a way that I think makes a lot more sense, right? So this is the METEOR example in that you just create, this METEOR collection of messages, right? You do a query on it by saying find, and it's gonna give you back some initial data if you have it cached locally, but it's also gonna open a real-time connection, or rather, the way that METEOR works is that there's always this real-time syncing going on. So this query that you get is always gonna fire these changes that you can observe. And you do that by calling observe changes, funnily enough. So you're going to get updates when things are added or removed, but this is like a normal message collection that you can then send into templates, right? And instead of just, you loop over the messages that are there. If you look at, this is our message list. You loop over the messages that are there, they're going to get rendered. But also any messages that get synced subsequently from the server, they're going to get rendered. Like this is all kind of hooked up in a nice way, in a kind of magical way, but it's also kind of nice, right? And this is what I think we want the real-time connection to be, is the thing where we go through our models, we use this pattern that we already know, the basic one that everybody in here said, yeah, I already know how to do that, but you get real-time with the same capabilities, right? So I hope I've kind of illustrated how these patterns have kind of helped me evaluate these different frameworks. And I want to wrap up here, but I like this quote. This is from our VP of Engineering. And when he said this, I knew that he had captured the core of why I felt like this would be a good talk. Because rather than kind of being inundated by all these solutions that we have to evaluate, it's much better to kind of get really acquainted with the problem, right? The thing that we're trying to do and how we expect to be able to do it, and evaluate these frameworks against that, right? Rather than kind of saying, how do I do this in Ember? How do I do this thing in Angular? My question becomes, I know I can do this thing, right? Like, I want Angular to enable me to do this thing. So I know what I'm looking for, right? I'm looking for my models. I'm looking for how I can inspect them. I'm looking for how I can register callbacks. And I'm looking for how I can nest views. And I know what to expect, right? That's been a huge win for me in terms of doing these evaluations, right? And so what I want to leave you with is, like, let's find a way to talk more about these shared patterns. Let's get these examples. Let's use GitHub. Let's get people to contribute. Let's find out how far these patterns are spreading across our community, and use them as a context for having a stronger basis for front-end development. And that's basically it. Wish we had more time for questions.